Welcome once again. It's Frazier Nation with your host, Timothy Frazier. And we're out here once again, hottest thing smoking since the steam locomotive was invented. Trained for, y'all young people. Anyway, we're in the geometry series and we're talking about 1.4, which is measure and classify angles. You don't know what classify means? Ladies and gentlemen, when I say classify, Uh, Brahman means name. So we're going to be able to measure angles, name angles. These are exciting times. So first and foremost, let's go ahead and give you a disclaimer now. You're going to want to pause this video a lot and make sure you get all the information in your notes. If it's on the screen, it needs to be in your notes. Okay? Now, during this lesson, I want you to be able to know students will be able to add angle measures using the angle addition postulate. Remember postulate, okay? This is just something that I'm giving you. I want you to roll with it. I'm not going to prove it. I'm just going to tell you that, hey, this is true, okay? In geometry, it's all about the name. What are we doing with this postulate? We're taking angles, we're adding them up, okay? So I just need you to know that. The essential question: how do you identify an angle as acute, right, obtuse, or straight? I typically don't focus a lot on straight angles because, linear pair and, all this stuff later. But let's remember, and actually this is kind of a get to know you thing, but look at this right here. This symbol right here means angle. I'm not going to write angle a lot. I'm going to use this symbol. So if I say angle ABC, I'm going to use this symbol. When I have an M in front of this symbol, that means the measure of that angle. So this means the picture. This means the picture. This means the number attached to that picture. Okay. The measure of the angle ABC is a lot to write, so I'm just going to write a little bitty M and then the angle symbol, which means the degree measure of angle ABC. Okay. When you're writing your angle measure, I want you to make sure that it's flat. And I don't know what that was, but anyway, I want you to write it flat. Okay. I don't want you to mistake it for the less than symbol, which is not flat. Okay. We're not dealing with him today. Okay. Next card. Key vocabulary. Now, I didn't cover anything up because everything is kind of important in this slide. I want you to look at our definitions. An angle is two different rays with the same endpoint. Okay? The two rays that we're talking about, those are the sides of the angle. And the endpoint we're talking about is the vertex of the angle. Okay? I need you to get familiar with these words, ladies and gentlemen. Angle, side, vertex. Okay? So let's look at our picture. Here's two rays, okay? Here's one ray. Here's the other ray. They're coming from the same exact point. Point. See my point? There's my point. There's my point. There it is. Okay. So the point that it's coming from, the vertex, here are your two sides. And there are four types of angles. I know you see three, but there are four types of angles. The three that I really like to focus on is the acute, which is 1 degree and 89 degrees, like everything in between. The right angle, which I know you guys have heard of before, that's when it's equal to 90 degrees. So it's like when we take and stretch these two rays apart and we can fit this little box right here. This means right angle, okay? And anything past 90 up to 179 is going to be an obtuse angle, okay? Straight angle, and I'll go ahead and just write this down. A straight angle is equal to 180 degrees. Whoop-de-woo. Okay? So, you guys have that in your notes. Let's go ahead. Next card. When I'm naming an angle, okay, there's a couple of options we can use, okay? I need you to pay attention to this. The name of the angle consists of 3 points typically. Okay, I'm not going to write typically, but typically you name an angle using 3 points. That's your most appropriate way to name angles. There are other ways to name them, but for right now, I want you to think 3 points. The vertex, okay, the point that the two rays are coming from always needs to be in the middle. Okay? So I want you to look at our first example. Our first example right here, how many angles do you see in this picture? Well, I have it written down right here. There are 3 angles that are attached to point A. Okay? So I have to be specific. Here's a little bitty angle. BAC. Notice vertex is in the middle. I can flip it around and say CAB and still talk about this same angle. Okay, so angle BAC or CAB. The next angle I could talk about is CAD, or flip it around and say DAC. Notice the vertex is in the middle. Finally, we're talking about the big angle, if you didn't know what your third angle was. The big angle, which is BAD, or flip it around and we're talking about DAB. Okay? So there's 6 configurations. Each angle can have 2 names. Okay? Right here, there's an exception. When you only have one angle attached to a vertex, so like right here, okay? I only have one vertex and I only have one angle. I can name this 3 things. I could call this angle MAR. I could flip it around and say RAM. Or since I only have one angle that I'm talking about, I can literally say angle A. Okay? I can't say angle A here. Okay? Go ahead and write that down. I can't say angle A here because I have 3 angles and I'm not going to know what you're talking about. Let's go ahead and say no, no, no. But for here, that'll work. Okay? Next card. Again, this is kind of the official book saying it. Let me go ahead and write you something a little bit cleaner, a little bit more efficient. The big angle, okay? The big angle is equal to the 2 small angles. Okay, so if I take the 2 small angles, okay, and I add them together, that's going to give me the big angle. Okay, so if, for example, I have this angle right here, 3 angles, and I have the small angle ABD, and I have the small angle DBC, then we know that it's going to be equal to the big angle. So here is my original equation. Let's fill in what we know. ABD is equal to 10 degrees. So write that down. 10 degrees plus DBC, which is 12 degrees. That's going to equal your big angle, which is the whole thing, which is 22 degrees. Okay. So basically, I guess what I want you to say is, hey, you got 2 small angles, you can add them up, and you get the bigger angle measure. Okay? Next card. More key vocabulary. Okay? When we say congruent angles, we're talking about angles that have the same angle measure. Bands make the angles dance. So I have 2 angles here, and the only way I can tell that they have the same angle measure is that they have 1 band apiece. L and N wouldn't be congruent because this has 1 band and this has 2 bands. That would make no sense. But let's call this angle measure 24. Okay, 24 degrees. If I know L has 1 band and O has 1 band, then I know that O also has to be 24 degrees. Or for example, if I had N and Z, if this was 102 degrees, then I know that this has to be 102 degrees as well. Cool? Finally, like we were saying with segment bisector, cut angle into 2. Okay, so you don't get a lot of options with this as you did with segment. It has to be a ray that splits the angle in 2. Okay, because remember, we're coming from the vertex A ray comes from a vertex. So a ray that splits this angle up into two congruent angles. So as you look at our angle JUS, ray UT is your angle bisector, okay? How do I know it's an angle bisector? Well, JUT and TUS, they both have one band. Remember, bands make the angles dance. So if this was, I don't know, 15 degrees, then what's TUS got to be? 15 degrees. Okay? Next card. Remember, pause this video if I'm going too fast, because I'm intentionally going fast so you'll slow down and write your notes. Okay, guided practice. We have a lot of them, so please, 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 write everything down. This is pertinent to your homework. Okay, number one, name all the angles in the diagram. How many angles do you have? We have 3 angles. Okay, so I'm expecting 3 angles. Remember, you need 3 points to name an angle, so let's go with the small one first. Let's call it angle PQR, okay? Or I could switch it up and I could say angle RQP. And what's in the middle? What's in the middle? Q. Okay, that's your vertex. That's supposed to be a point right there. Okay, next we have angle RQS, or flip it around and say angle SQR. Okay, RQS, SQR. Finally, we have angle PQS, or we could flip it around and say angle SQP. Okay, so we named all the angles. We gave their alternate names. And which angle is the right angle? Well, here's your indicator. PQS is your winner. This is your right angle. Okay. Draw a pair of opposite rays. So here's a ray right here. Remember, I need an endpoint, and we're going to go to the right. Now, when we say opposite, we mean the complete opposite direction. So there's one ray. Here's the other ray. Okay. What type of angle do these rays form? Is it a right angle? No. Acute? No. Well, maybe it's obtuse. No. If it's an opposite ray, that means that we have made a straight angle. Okay. Next card. Given that angle KLM is a straight angle, I want you to find the measure of KLN and NLM. Okay. First and foremost, we need to know that this is 180 degrees. Okay. Let's also remember that the 2 small angles is equal to the big angle. Okay. So let's write our equation down. I know I don't have a lot of room, so let's go ahead and say it. The measure of angle KLM is equal to the measure of angle KLN plus the measure of angle NLM. Okay, plug in what you know. We know that this is 180, and we know that that's equal to 10x minus 5 plus 4x plus 3. Okay? Combine like terms. So this is 180 equals 14x minus 2. Okay? So let's say combine like terms. Ooh, my tablet is not loving me today. Ugh. Okay, combine like terms. Okay. Still got to combine like terms here, so we got to add 2 to both sides. Okay. So I have 182 which is equal to 14x. Okay. Divide both by 14, because that's the opposite of multiply. And, sorry. When I do that, then you get 13. So 13 equals x, and I kind of like my variable on the left. Okay, and I'm done. No, I got to take this x and I got to plug it into one of these x's right here. All my x's live in Texas. All right, so I have 10. I know what x is, so this is 13. And then I have minus 5. So I have 130 minus 5. So I know that what I plugged in is 125 degrees. Okay. Now, do I have to plug in x here? I can. But remember, if this whole angle is 180, okay, and we know that this angle is 125, then we know that we have to take and subtract 125 from 180, and we'll have this angle measured quick, fast, and in a hurry, which is 55 degrees. Okay. Now, if you just one of them people who just got to get right, you can plug it in. We have 4 times 3 plus 3. So this is 52 plus 3. And lo and behold, we got 55. How do we know we're right? 125, 55 gives you 180 degrees. You knew. All right, let's just go ahead and hop into this. It's the same type of problem, so I'll just fill out the work for you. Let's go with two small angles equal to big angle. So I have here the measure of angle EFG, which is equal to the measure of angle EFH plus the measure of angle HFG. And then fill in what you know. We know that the big angle is 90 degrees, and we know 2x plus 2 plus angle addition postulate, people, plus x plus 1. Combine like terms. Combine. 90 is equal to 3x plus 3. Okay. Subtract 3 on both sides. We get 87 equals 3x. Divide both sides by 3. X is equal to 29. Okay. Not finished because it says find these two angle measures. Okay. So if I plug in x right here, I know that this is going to be 2 times 29 plus 2. So I'm going to have 58 plus 2. So I know that this angle measure is 60. And then we know that 90 minus 60 is 30. Or you can go ahead and plug it in. 29 plus 1, which is 30. Questions? Bring them to class. Okay, number 5. Identify all pairs of congruent angles in this diagram. Okay, so when I look at this diagram, I have two angles that have two bands, and I have two angles that have one band, and we don't have more than one angle at each letter, so I can just say that angle P is congruent. You don't have to write the word, use the symbol. Is congruent to angle R. Okay, and angle T is congruent to angle S. Okay. Now, remember, in geometry, if it's not in your picture, put in your picture. So when we say in the diagram, I know you were probably thinking like, Fraser, what diagram? So this diagram right here. we know that PQR is 130 degrees. Okay, 130 degrees. We don't really need it, but put it in anyway. QRS is 84 degrees. And TSR, that's 121 degrees. Okay. So find the other angle measures in the diagram. Well, we have two left. We already know this, okay, and you guys don't know about interior angle measures yet, so that's why they gave this to us. If S is congruent to T, they both have one band, and we know that that means same angle measure. That means that angle T, or let's go ahead and be official, angle PTS, and that's the measure of angle PTS, is equal to 121, okay, because they both have one band. And then finally, the measure of angle P, or the measure of TPQ, has to be 84. Okay. Okay? Questions? All right. Now, geometry is going to start getting a little heavy with a lot of words, so let's break things down. We know angle MNP, straight angle. People, 180 degrees. Okay? Ray NQ bisects MNP. So it says draw angle in MNP. So we got a straight angle. So that means here's an angle. Okay? It's straight. And we're going to call this MNP. So here's your M, here's your N, here's your P. And we know that ray NQ is probably going to go straight up. Okay? Use arcs, bands, to mark the congruent angles in your diagram and give the angle measures. So we said that ray NQ is bisecting. So that means that this angle, and this is the only time you'll see me use a round band, we know that this angle has to be congruent to this angle. They both have one band. And since we have two angles that are equal to 180 degrees, we just divide by 2, and we have 90 degrees apiece. So we know that this has to be 90 degrees, and this has to be 90 degrees. You have any questions? Well, there's Schoology.com. Okay. There's YouTube. I don't know why you use YouTube, but whatever. There's my email. There's class time. So anyway, Fraser Nation signing off. Let's get it, and good luck with your unit test. Peace.